To the Licentiate thesis in human-computer interaction by Khanh standing here, and he will present the name of his topic and of the supervisors. The opponent today, or the discussion leader, is Stefan Seipel from University of Gävle and Uppsala University. Please welcome. And the two supervisor and co-supervisor are here, and one co-supervisor is in Zurich and can see us over the streamed presentation. Thank you very much for being here, and I give the word to Yui, please. Okay. But you have a microphone already.
Yeah, I have a microphone.
Great.
Yeah, thanks, Martin. So, welcome everyone. I'm Yui, and today I will present my licentiate thesis, which is entitled Towards Enhancing Awareness in Designing Collaborative Computing Systems. This thesis is a compilation of all the work that I have done in the first 2 years of my PhD study under the supervision of Professor Morten Gen and two co-advisors, Professor Andreas Kunz in ETH Zurich and Professor Michel Chautron from the Software Engineering Division of Chalmers University of Technology. So this is the timeline, the agenda of the presentation today. First, I want to talk about the context of all the works that I have done. Next, I'm going to talk about the core concept of the thesis, awareness. And then we're going to move to the contributions, where I'm going to say about Hello? Hello. Okay. And then in this part, I want to talk about how all the works that I have done contribute into supporting awareness in collaborative systems. And then we will conclude and briefly discuss about what I'm going to do next in the rest of my PhD study. So, now we start with the context of the works that I have done. So the first context that I've been doing in my PhD study is the Merkle project. It's a collaborative project between Chalmers, and the main academic partner of the project is ETH Zurich, with a number of industrial partners like Ericsson, Semcon, TouchTech in Sweden, and AVS in Switzerland. The main aim of the project is to produce a software solution to support remote collaboration. And one of the most important constraints of the project is not to produce any new hardware, but rather we try to rely on off-the-shelf hardware and build software solution on top of that. Besides that, during my PhD study, I also had several collaborations with several academic partners like HCI Lab in National University in Singapore or the University of Science in Vietnam. I work with some former colleagues there. And one of my former colleagues in the lab right now is working in Stuttgart University in Germany. So now we move to the main concept of the thesis, awareness. Actually, there are several definitions of awareness, and there are still many debates about the definition. But the most popularly cited one is that awareness is an actor who is aware and understands the activities of the others, and then he will adjust, align, or integrate his activities tactically or unobtrusively. For example, if I walk into a party and I see some friends talking together, I want to join them. Usually I will listen first about what they are talking about. I want to know about the topic of their conversation. And then when I know the topic of the conversation, I will start talking about that topic. It means that I understand the activities and I adjust my activity accordingly. So in collaborative system, awareness can be understood as the communication and interaction not only between human and human, but also between human and computer. In human, for example, we are working together on a shared text editor, and I see your cursor on the shared text editor, so I know that you are working on that error. So I will try to avoid working on that error to try making conflict with you. Between human and computer, for example, the computer know that you are working on image or you are working on text, and then it will provide the suitable tools for you to manipulate the media. And the most important and also the first question when asking about awareness is aware of what? So depending on what information that the actor is aware of, we have different ways to categorize awareness. We have social awareness, we have contextual awareness, we have workspace awareness. Of course, in the literature, I also found other kind of awareness, but workspace awareness, contextual awareness, and social awareness are the most popular thing that I found in the literature. So that's why in this thesis, I mainly focus on these types of awareness. So now we're going to briefly go through each type of awareness. So workspace awareness is understood as the up-to-moment understandings of the other person's interaction within a shared space. A shared space could be a physical space like a tabletop system or a large display. A virtual space could be like a shared text editor where people work together online. So, for example, working on tabletop and standing on the side of a tabletop, other people will see that, so they will standing on the other side instead of on that side in order to avoid conflict. And similarly with the virtual space, for example, shared text editor, people see the cursor of a user and they will try not to interact with that in order to try to avoid conflict. Contextual awareness. Before talking about the definition of contextual awareness, we're going to talk about firstly the definition of context. Context of an actor is the part of the operating environment of the actor, and the actor can sense. For example, is the location of the actor, or is the identity, or whether it's the state of the people around the actor. So when we have this definition, based on this definition of context of actor, then the definition of contextual awareness is the idea of adapting the behavioral patterns depending on the contextual information that the actor sends. For example, when we work together with the computer knows that we are working with image, then it will give us the tool to manipulate the image. If the computer knows that we are working with with text, it will give the tool for us to know to work with the text. Or for example, with Facebook. On Facebook, we can choose to unfollow some specific person, and then Facebook will not show us any new update from that person. It means that Facebook adjusts its behavior according to our preference. And last is social awareness. Difference from the contextual awareness and workspace awareness, because this type of awareness can happen between computer and human and human. Social awareness right now is only about human and human. Is that a person is aware of the situation of the other people. For example, I see you working. So I know that you are busy at the moment, so I will not disturb you at the moment and will come back later. So it means that I'm aware about your state and what you are doing, or even what kind of topic that you are talking about. So those are the type of awareness. So how these type of awareness are supported in collaborative system, and how did the works that I have done contribute to that? Now we will go through all of them. Actually, the works that I have done in this thesis are quite diverse. They cover 4 main topics. The first one is interaction with tabletop. The second one is social network size. The third one is in distributed creative group work systems. And lastly is in the system that supports vibro tactile feedback. So we will go through each of them. So on tabletop, how are types of awareness supported on tabletop system? So on tabletop, awareness, so workspace awareness and contextual awareness are supported by different works. For example, related to workspace awareness, you can see that in the first picture, people divide the screen of the tabletop into different areas. So, for example, the two triangles are actually the personal space for each user. So the object on that personal space are supposed to belong to the user, the corresponding user. And the middle part are the shared space where people have the freedom, all the freedom to interact with that. But in this case, the personal space is fixed. To help the user dynamically determine the personal space, another work allows user to create a circle and all the objects within that space are supposed to belong to the user. Or another work, which is in the third image, is that the user uses proximity sensor to send the location of users around a table, and then they will allocate all the personal spaces to the corresponding people. Contextual awareness is also supported on tabletop system. For example, in the first picture, when interacting with tabletop, beside the intentional work, which is generated, for example, in this case, is the tip of the pen, user also generate unintentional touch, for example, the touch of the hands of the user. And sometimes this is undesired by the user, so the system will adjust the user interface so that it's not occluded by the unintentional work of user, intentional touch of user. Or the user can use the pen and draw a path, and then the menu will display according to the path so that it's not occluded by the physical object as well. Or in the third image, you can see that depending on different parts of the hand touching on the surface, the application will show different user interface and different tools. My contribution in this case is also targeting the unintentional works, the unintentional touch of user on the tabletop is in the first paper towards leaning aware interaction with multi-touch tabletop. So this is the inspiration. As you can see, when people work with tabletop, beside the intentional touch, for example, in this case, the finger of the user, they also generate some unintentional touch. For example, these parts. In most of existing work, they just disregard this touch. They just try to remove this unintentional touch. But we believe that this kind of unintentional touch may contain information about the posture of the user or even the mental state. For example, in this picture, you can see that when you look at the posture, you can see one actor is active while the other actors are somehow passive in the communication. So what we want to do is that we want to recognize different types of unintentional gesture, and from that we envision some use scenario. For example, so in this work we categorize the unintentional work into 4 classes of unintentional interaction. In this paper, we refer to unintentional interaction as leaning interaction. So the first one is elbow, next is forearms, the third one is partial hands, and the last one is full palm. We classify them based on the shape, the size of the touch, as well as the parts of the body part that generate the touch. And then we built a proof of concept algorithm to recognize different types of unintentional up-leaning gesture. And from that, we envision some use scenario. For example, when we can detect different parts of the hand like this, we can dynamically determine the personal space of the users and as well as the shared space as well. Or we can also adjust the widgets around the location of the user so that the user is convenient for user to access the widgets. Or for example, in the conversation in collaboration, we can determine the state of the user, which one is more active, which one is passive, and then we can give some suggestion if necessary. The next area is social awareness, is awareness in social network size. So actually, in social network size, contextual awareness is the most popular awareness supported. For example, when you are using YouTube, when you open your homepage on YouTube, you can see a list of recommended videos, which are similar to what you have seen or you have watched so far. And YouTube just predict that this could be interesting for you. Or for example, on Facebook, when you click on the video, Facebook will show you a list of the videos published by the same publishers. Another feature of Facebook that supports awareness that is related to the contribution of my paper is the Facebook on this day feature. Facebook on this day reminds us about some event that happened in the past on the same days as today. It's pretty nice because it reminds us about something happened in the past, but because sometimes we are too busy and we forget that. And when we reminisce about this type of event, we probably get emotional, and it can strengthen the relationship between us and the people involved, for example. But sometimes this feature also has some limitation because it solely relies on the timestamp of the event. So sometimes it can remind something that could be happy in the past, but right now it's quite sad. For example, some weeks ago, this picture reminds me about a picture that I took together with my grandmother, who passed away just some days after the day I posted the photo. So, but we realized that supporting reminiscence in the user by suggesting something similar to the user is viewing is also a very interesting topic to investigate. So that's why we contribute to this through the second paper. Now and then, a social networks-based photo recommendation tool supporting reminiscence. So why is that? So this is the inspiration of the photo. So in this of the system, in this photo you can see this is from a photography montage which was extremely viral on social network around 4 years ago or 5 years ago. In this photo, people combine the photo of the people or the things at the present and how they used to look like in the past. And when they share this photo on social network, everyone just got really emotional and nostalgic. And when looking at this kind of photo, because they remember about the past memory related to them, and they appreciate the present more because they know that when time goes by, it can take away many things that they're having right now. But today, when using social network, it's very easy for us to share photos, but because of that huge amount of photos shared, we barely have time to revisit them. We think that it's sort of wasteful because we think that those photos may contain some information that can trigger the positive reminiscence in the user, and then that can strengthen the relationship between the user and the people around them. So that's why we design Now and Then. With Now and Then, when the user is sharing a photo or when they are browsing the photo of themselves or their friends, for example, in this case, the left photo, this is the photo that the user is sharing. The system will automatically retrieve all the photos of the user that they have shared in the past or their friends have shared in the past, which visually looks similar to the photo that the user is sharing. We rely on the visual similarity between photos in order to avoid triggering the negative reminiscence in the user. And we also design a side-by-side view to allow users to compare the things about how they used to look like in the past and how they look like at the present to hopefully trigger more emotion in the user. And we also perform a user study with this tool, and we come up with several interesting insights about how users interact with the past photo, as well as how users use different functions and features of the application. And this serves a design consideration for the future application. But the concept of Now and Then is not only for the social network. We also envision about the context of augmented reality. Right now, augmented reality devices are emerging, and we envision that one day if we wear the glasses, we look at some scene. For example, in this picture, this is the picture at the present moment of a city in Vietnam. The application can successfully retrieve the photo of how that location looks like 50 years ago or 30 years ago. And the application can also can blend the two photos together. So imagine that one day you wear the glass, you look at your house, and you see how it looks like 100 years ago. It's just like a time machine. I think that it's not only good for triggering reminiscence, but it's also beneficial for history learning or for museum as well. So that's about contribution in the second field. The next field is supporting awareness in distributed creative group work system. Creative group work system are basically the system that support ideation or brainstorming. For example, but right now, most of the work related to creative group works are usually carried out in the collocated settings where everyone needs to be collocated in the same place in order to maintain the communication on the users. In the distributed settings right now, creative group works are not that effective. There are also a number of works trying to support this. For example, in the first picture, you can see a system which is namely distributed designer outpost, where two sides of the collaboration, we have two groups of designers, both of them have whiteboard, and they can stick the sticky note on the whiteboard to perform the brainstorming. And you can see the light on the screen is actually the visualization of the shadow of the remote participant. So when looking at that light, people can predict where relatively in front of the screen the remote participant is standing. So that will maintain some sort of peripheral awareness on the space. The next work is Holoport. In this part, people can show the image of the remote participant so that we will have the feeling that we and the remote participant are working together through a glass. We're writing on something and the other person is standing on the other side of the glass, working together. The next work is Collaborate. So instead of giving the impression of working through glass, Collaborate gives the impression that you and the remote participant work side by side together on the same canvas. And recently, due to the emergence of depth camera like Kinect, the user also used Kinect to extract the point cloud of the remote participant and try to visualize that on the big screen. However, the main problem with this system is that it's supposed that the two sides have some sort of fancy hardware like this, but we look at the scenario of the individual who are traveling and who only have, common devices like tablet. How can they participate in this thing? And whether, and we look at the literature, and there is no work that try to support the remote participant in such scenario. So that's why we design a system which is called Digital Metaplan, and we explore how the system is used in distributed brainstorming. So the system is designed based on facilitated brainstorming. Facilitated brainstorming, as you can see, we have one facilitator running the brainstorming session. He's standing at the whiteboard, and other members, other participants in the brainstorming session are sitting. And if they have any idea, they need to discuss together, and then the manipulation on the post-it note on the whiteboard would be performed by the facilitator. This is typically one of the most common settings in collocated brainstorming. However, when it comes to distributed brainstorming, usually this setting is overlooked by the existing solution, because when it comes to distributed brainstorming right now, people brainstorm over the internet. People suppose that all the people have the same role. So that's what make remote or distributed brainstorming right now not effective. So that's why we design a system which is called Digital Metaplan. Digital Metaplan contains two components. The first one is an application running on the whiteboard, which is used for the collocated settings and by the facilitator. So the facilitator will run the brainstorming in a collocated room with all the people, and all the post-it note generated will be displayed here, and all the brainstorming discussion will be happening on this whiteboard. For a remote participant, they can remotely participate in this brainstorming session using a mobile application on which they can monitor the brainstorming whiteboard as well as perform pointing when they want to discuss to a specific idea. So this is how the system in use. Yeah, we have found several interesting interaction of user with the feature designed by this, with the feature of the system that help them in coordination and being engaged in the brainstorming session. And last one is how awareness is supported in vibro-tactile feedback support system. So briefly, vibro-tactile feedback is the feeling of vibration, is that your skin feels the vibration. So vibro-tactile feedback has been widely used to enhance awareness of user in collaborative systems because digital system, it's very easy for a user to manipulate the information, but the thing is that the content is virtual, is digital, so sometimes you lack up the physicality, the physical feeling, like when you interact with a physical object. And when lacking up such kind of feeling, it may affect on the experience of the user. And vibro-tactile feedback is widely employed to somehow fulfill that feeling of the user. For example, in the first picture, when the user interacts with tabletop, you can see that on the tabletop display a quite complex texture, but when you touch on the screen, you cannot feel that texture. So by equipping the user with some sort of vibrator, the user can feel different tactile feedback depending on the gesture. So that will enhance the experience of the user. And they also improve the workspace awareness of user as well, because the user may know where on the tabletop he's interacting with. The second application is in a collaborative game, augmented reality game. Two users are playing tennis together. And in order to raise the awareness of user about whether the balls is outside of the court or whether they lost a score or they win a score, the user will generate a vibration from the mobile device. And for another one is an example in an emerging platform right now, which is virtual reality. In virtual reality right now, we can see that we point the object, but we lost the physical feeling. So by equipping the vibrator, the user, when they touch some virtual object, the vibrator will generate the vibro-tactile feedback. So it's going to be more lively for us to interact in the virtual space. My contribution in this area is not an application for using vibro-tactile feedback, but a new way to intuitively author and create the vibro-tactile feedback on tabletop. is in the paper, Ubital, a finger-worn I/O device for tabletop vibro-tactile feedback pattern authoring. So how is vibro-tactile feedback right now is being authored? These are some common examples. For example, on mobile device, you can use the graphical screen. You can adjust the intensity. But this kind of graphical interface, you can only adjust simple vibro-tactile feedback because you can only change the intensity. If you want to do something more complex, you want to create different pattern of vibration, you need to use the second screen. But it's not intuitive because you have to map from what you feel on the skin into that kind of wave shape. So in my master degree, I explore a way to intuitively create the vibration pattern from the movement of the user. So when the user hold the tablet and they go around, the tablet will record not only the audio and the image, but also record information from the accelerometer. And then we will map from the motion recorded in the accelerometer into the vibration pattern. But this is just feasible for a small device like tablet. Where the tabletop is big, we cannot carry around like that. So that's why we came up with the design of Ubital. It's a ring. Basically, you wear a ring. On the ring, we have a accelerometer and a couple of sensors. So if you want to create a vibration pattern for an object, you wear a ring, you wave your finger like this, and depending on how you wave the finger, we will map the movement of the fingers into vibration pattern. And when you want to feel the vibration pattern that you have created, you just need to touch on the object that you have authored the vibration pattern, and the ring will generate the vibration because in the ring we have the vibrator as well. So those are all the things that I have done in the first 2 years of my PhD. In short, I have explored several ways to improve awareness in collaborative systems on tabletop, on social network, on distributed creative group works, and to support vibro-tactile feedback on tabletop as well. I have learned several skills as well because my background was from software engineering. So when I started doing PhD, I had no knowledge about understanding user, how to design, to evaluate the system, interactive system. And of course, in order to learn that, I also suffer a lot of despair due to paper rejection. And now it's time to narrow down the research topic. And I realized that the mobile computing is not very well supported when it comes to distributed creative group work, how to make the user using tablet, commodity device, more engaged in brainstorming session. So I think that we should, in the rest of my PhD, we try to explore this topic. So that's it. Thank you for your listening, and I think that now we start the discussion. Yep.
And time for this discussion is probably so we'll go on for a while. But I think Stefan has a train, but let's see what that train is. I'm not sure we can totally see it, but I'm afraid it's a little late. I think that's not a problem. And then, but I don't think we have enough time.
Is this on? The microphone, is it on? Okay. Probably I wouldn't even need it. Yeah, first of all, thank you very much for inviting me here to Gothenburg. It's always a pleasure to come in here and either being part in a committee, grading committee, or as a discussant for the discussion leader for the thesis. Very nice work that you do here. and probably I should sit down also here. And I see my role here as a, of course, an opponent, discussion leader.
Yeah.
But I wouldn't call it like a battle.
No. I mean, the matter is the rest of my PhD.
let's keep this a critical discourse.
Yeah.
On the work that you have done so far, and hopefully by the end of this session, you have narrowed down more how you will go further. Okay, I have a. Okay, right. Yeah. Oh, now I also can hear that it's on. Thank you. Very interesting presentation, very well prepared, excellent, and it gave me a lot of insight which I did not have before. Yep. From simply reading your summary and also the papers. I truly recognize that you put into a lot of effort, software development-wise, and into this, and it's a big diversity of different works. It's very impressive, and there are a lot of very interesting and genuine ideas behind that. But of course, I should also be a little bit critical here, not only telling what is good here, and also question parts of your work. I thought of starting with the papers, paper-wise, and probably then we can have a short view into your summary, and also discussing a little bit what could be done in the remaining period. So, if we start with paper number 1, this was about the leaning gestures, or the unintentional touch contact with the surface. Would you characterize this work to be a major contribution within the technical field, or within the humanity field, or in the HCI soft part?
I would say that is a technical contribution, because most of the part is a technical contribution. Yes. Although the accuracy of the algorithm in the paper is not really outstanding, but I would say that we contribute a lot of effort into that.
Oh yeah.
Yeah.
We can go back. I will get back to that later, to the result part.
Yeah.
Okay. So you wrote about depth camera. I did not quite understand in this context what the depth camera was used for. Did the visual images not deliver enough information for segmenting out these contact points? Let me see where you write about that. Or probably it's only a spelling error in the text, because I was triggered by the fact that you speak of depth cameras. But you used a visible camera only.
No, we don't use a visible camera.
Visible camera.
Yeah, we use the PixelSense tabletop.
Yes.
So in the PixelSense, you use the PixelSense technology. So almost every pixels on the screen can recognize the touch of a user. So we get the somehow so-called depth image captured by the table.
Yeah, right. The thing why I got confused is because it says on page 41, the contact areas could thus be recorded using a depth camera. That was confusing me quite a bit. Okay, so it's simply the visible channel that you evaluate here.
Yeah.
Okay. And then you also say on the same paragraph, you did some tests here, sketching tasks. You had the counterbalanced order of tasks between the participants here, right? What was the importance of the counterbalancing here?
Well, I would say that the counterbalance was not that important in this way. So actually, my role in this user study is that I came up with the design of 3 tasks. So that's going to be, it's going to generate different kind of unintentional touch of the user.
Yes.
And then when it was carried out, we had one colleague in NUS who coordinated that. And then this is how Yeah.
I understand that in this part of the study you only used this user interaction and this experiment in order to collect data, raw data, as an input into your segmentation later on.
Yeah.
And that is why I was confused about
counterbalancing.
Because usually it's when would it be necessary to use counterbalancing?
Yeah.
What is it used for?
It's used for in order to avoid the expectation in user.
For instance, expectations, also learning effects. But you're not even looking at user
no.
here.
Yeah, no.
Okay.
Yeah.
So you also say that based on this data, you did some manual analysis and classification of the touch data.
Yep.
What did that imply? Did your experts hand draw the outlines?
Yes, we recruited some sort of volunteer in order to trace all the boundary of the touch interaction.
Yeah.
And then we, me and my colleague in the US, we look at the pattern of all those things to come up with the categories of all those things.
Yeah. And the input for this task, for this manual delineation task, was it binarized images or was it these raw data, these intensity images?
This was the raw data.
It was the raw data.
The raw data with the trace.
Because then I would expect quite a big inter-observer variation here between those experts.
Yeah.
Did you try to control for that or estimate variations in between those experts?
No, in this user study we didn't have that.
Because you use this data set nevertheless as kind of a ground truth then for training your system.
Yeah.
So you might also have big variation already in the input data set, which we do not know so much about here.
Yeah.
By the way, would it be possible to have, for the audience, because now we are talking pretty much details in the papers and there are figures in the
Okay.
I'm not sure, is it possible to have it on the big screen? Or would that, or probably the audience can follow having the book. Yes, I said it, page, I will add the pages. Yeah. Yeah, well, what I was previously referring to was the delineation of these contours, and that's seen for instance, in figure 2 on page 43, where it is not, I mean, it's up to the observer to decide where goes the true contour if you look at these smooth transitions of intensity images. Okay. Then you say that for classification, you use active shape models.
Yep.
ASM.
Yep.
And the paper refers to statistical shape models.
Yep.
Can you clarify to me a little bit better how you did here? Because for me, active shape models or active contour models are more something like, for instance, snakes or live wire algorithms, which work on contours and propagating contours in an adaptive manner based on information in the images, whereas statistical models are something different. So where comes, is it contour-based models or is it, I get a little bit confused here as well, statistical shape models. Do you work on contours or do you work on regions?
Well, to be honest, I did not contribute into working on the algorithm, because this is the part which was mainly contributed by my colleague in the US. She was working on computer vision.
Yeah.
So that's why what I did in this project is that I run the user study, I collect the thing, we analyze to the categories, and then I develop a demonstration application on top of that.
So you have not been primarily involved in the development of the computer vision algorithms. So you simply reused them.
Yeah.
Okay, that makes it very clear.
Yeah.
Mm-hmm. Yeah. Then I had more questions on that. I understand if you probably cannot answer, but I posted them anyway. They might not be so difficult. You probably know anyway the answer.
Yeah.
For instance. you have to, if you do this comparison using the normalized cross correlation, of course you have to have some kind of a similar reference frame here, and you're doing rotations here. So based on how do you determine the axis, the principal axis you are rotating, basically? I mean, you have samples of your touch interactions, and you have somehow to determine a reference axis which you decide to rotate.
The reference axis, as far as I know, in this project, is that we use the top left coordinate of the table.
Okay. You have a global, absolute global coordinate system.
Yeah.
Okay.
Yep.
Mm. Yeah. And yet, to rotate these samples, you have to determine the rotation angle.
Yep.
How was that determined then? I mean, you get a bunch of different samples.
Well, in order to do that, so actually we determine the ellipse around the touch, and then determine the major axis of that.
Okay.
Yeah.
Yes, the ellipsoid and the major axis.
Yeah.
Okay. So that would fail probably on of course, on rotation symmetric contact points, but there, on the other hand, it's not important to have the rotation correction. So, okay. Then you also said that getting back to this manual delineation of the contours, you use 7 contour points which were manually defined.
Yep.
Can you give an example of? Now we actually should have something to draw on. Probably you use this one.
Yeah.
So, can you give me an example of a touch point, how it would have looked, and how you would have delineated it? Simply to give us an idea of, and then you use these 7 points, contact points, to describe a spline curve or a linear model.
Well, I didn't get involved into that process because it was done in Singapore. So that's why I don't know how to explain the process for you.
Okay.
Yeah.
Okay, then we rather skip it. We probably will need the whiteboard anyway.
Yeah.
Later on. Okay, classification, I had questions. So you collect samples and do some manual assignment of these samples and divide them into classes, and then you are training. You're not really training, you define basically classes of similar contact points and create an average footprint, which is shown in figure 2D. And then you calculate the normalized cross correlation. And you say a threshold of 0.3 is what you employ here. Yep. Is this something which has shown to deliver best accuracy or precision?
I suppose to be.
Yeah.
Yes. Although the whole computer vision was not done by me, but I think that the threshold were determined manually, to reach the optimal value. Yeah.
Probably by iterative testing.
Yeah. Yeah.
Not so detailed technical question, but nevertheless, if you flip over to page 46, you have in figure 4 on the right-hand side, you have a situation where there are several contact points.
Yep.
In fact, you have it in the center also, but I picked this one. Would your system be capable of identifying several such different interaction points?
Well, obviously in this picture, you see that so the rectangular one is something that we know is the object, so we can actually remove that from the picture. So the system right now can identify. Yes, the system can identify multiple parts there,
yes.
But of course there is some error depending on the cases as well. Yep.
But you use basically what you also later on suggest in your conclusions and for future work. You say that this could be used in order to delineate and identify private territories.
Yep.
Territories on the tabletop.
Yep.
How would you assign the different contact points to individual users? How you make sure that the different contact points not belong to different users? Would you use the side of the table as?
So yeah, I would say that. So for example, we basically we can estimate the orientation of and also whether it's the left hand or the right hand.
Oh yeah,
so
I see.
Of course we can suppose that okay, the right hand this way and the left hand this way, so they are supposed to belong to one person or something like that. For example, if we found that the left hand like this and the right hand like this, it's not very likely that it belongs to the same person.
Yes.
Yeah.
Okay. Let's have a look into the part where you present your results.
Yep.
And because this is the part where you have been mostly involved in.
Yeah.
You are stating accuracy here. And my first question would here be, are there alternative ways to express accuracy? You're feeding the system with with samples of 4 different classes and let your classifier identify them. Okay, we are on page 46 in the table. And you have the recognition output.
Yep.
And quite apparently there are correctly classified and there are misclassified inputs. So what you do is here you present the number of correctly classified inputs of a class divided by the total number of inputs for that class.
Yep.
And this is accuracy. Are there other aspects of accuracy or of system performance? Could you do it in an alternative way also? Describing and quantifying the fitness of your system, the performance of your system.
Yeah, I mean, in terms of evaluating the performance of the system, we have not only accuracy, we also have the, because we have, as far as I remember, we have 4 categories, is false positive, is true positive,
right,
etc. So based on those numbers, we can come up with several indications for that.
Yeah, this is where I'd like to get to, because what you have is you have all the data there, and you have what you actually what you say is accuracy here is actually the true positive rate. We still have recall value. That's right. And more interesting, actually, which more do we have? Recall value. I don't want you to denote what recall value is. But if you talk about the positives, there are true positives. Are there other positives also?
Yes, there are false positive as well.
Yes.
So it's basically that the system recognizes that is this kind of category of touch, but it's not really that category of touch.
Yes.
Yep.
Or the system. Yeah. In this particular case, the system would identify a class even though it was a different class.
Yeah.
Right.
Yeah.
That would be the false positives. So yeah. So what you show as accuracy here is the true positive rate, also called as the sensitivity usually in classification. And the false positive rate is the specificity, meaning that if I'm getting a result, a predicted result, how likely is it that the input really was according with this result.
Yeah.
And if you look at the specificity, the false positive rate, you have fairly high false positive rates in your systems. If you go for instance, class 3, there we look at the vertical numbers.
Yep.
Actually, there are 46 are classified as class 3.
Yep.
But there are many others where the inputs have been different things, class 1, 2, and 4, which also have been identified as class 3.
Yep.
So you cannot really rely on that. If your classifier tells you, oh, this is gesture 3, that it really was gesture 3. It might have been something else.
Yep.
And if you calculate those numbers, you arrive at false positive rates of 39% on class 1, for instance, 30% on class 3, 32% on class 4, which is fairly high rates.
Yeah, it's. Yeah, for me, I was in the next step. If I can improve the algorithm, I wouldn't use the ASM model anymore. Instead, I think that I can use the deep learning on social or neural network for this task.
Okay. Yes. Speaking about the segmentation recognition part. Yeah. So I think we'll have a look at paper 2.
Yep.
There was an initial thought that struck me immediately. You have a declaration of your contributions, and there you say, I was the originator of the idea to the paper, and also the concept designer, designed, ran the pre-study survey. You did most of the work here.
Yep.
But how come you're not the first author on the paper?
I gave my colleague the first position of the author because he needs that position more than me. Well, the thing is that he came up with, because he has the algorithm for this for this purpose, he has the image retrieval algorithm, but he wants to publish a paper about CI, but he has no background about designing interactive application.
Yeah.
So he come to ask me to help him. The thing is that I don't think that this is really the main focus of my PhD study. So that's why I decided to give him the first position, because it's more important in his university.
Okay.
Yep.
But what you're also saying here is that in this part it's about also there's a lot of image processing and pattern recognition involved. Also this part again is the part where you have not been so involved so
deeply.
I'm not.
Yeah.
Okay.
Yep.
Okay. Oh, that's a pity, because again I had a lot of questions. We will touch them anyway, and I will not drill too deep into them if you can't answer them. You speak about geometric consistency here on page 63. I simply wanted to know what you mean with geometric consistency. On page 63, quite in the middle of the text, in order to check the geometric consistency of candidates, spatial verification is performed.
Yeah, I guess what it means in this case that, for example, if we detect the feature A and the feature B like this, we're going to check whether the probably it's not only two features. I think in order to check the geometric consistencies, we need to consider the relation between different features to see the relative our attention between them or relative distance between them.
More like the spatial distribution of those features within the image rather than the features only. Because that leads me over to the next question I had. What kind of features do you extract from the images, both for training and later on for search? Is it point-like features, of sift features, or is it corner points?
Well, of course, the color feature is not used in this algorithm. We also use the feature. I think the hard-like feature was also sometime included, but we use a list of many features in order to improve the accuracy of the system. I still haven't looked at the code to know about more about the feature.
Okay.
There was a report which is actually the original algorithm of the paper included there. So if we take a look at that, we can see. You can see that in the offline indexing, there is a mention about the Hessian affine detector, shift descriptor, and also used even root shift as well. Yeah.
So these are all, I would say, very localized features.
Yeah, localized.
They don't carry information about where in the image they are.
Yeah.
And that's more or less a suggestion for future work here. It might be interesting to try to extract higher level features, which describe more complex geometric features in your images.
Yeah.
But probably this is beyond the scope of your personal research.
Yeah.
Okay. Yeah, I skip a number of questions I had on the recognition part, but let me go back to the point. At some point, you are stating also here on page 65. You say our visual feature-based image retrieval system achieved a mean average precision of 82.4%.
Yep.
Mean average precision. First of, how do you determine precision? And do you mean the number of correctly detected? Again, is it the same kind of measure that you previously called accuracy?
Yep. Yeah.
Okay.
Yep.
So here's precision accuracy.
I think that this term is more precise because I already checked quickly on Wikipedia, and this term has been explicitly defined. Yeah.
And then you have this mean average precision.
Yeah.
The mean of the average, or it's like double. Is it the mean precision average? But the precision, you have a data set. You run a test here with this Oxford building data set, which is quite popular to use for classification studies. You have 5,000 images in there. Did you pick these 5,000? How many of them did you use for training, and how many then did you use for retrieval to test your classification results? Can you say that?
I haven't been involved into the training and testing this, so at that time.
Okay, we can skip it.
Yeah.
Yeah. And also you mention the number of 1.9 seconds, almost 2 seconds for retrieving relevant photos. Is that on the handheld device, or do you have some kind of a server-based?
We have server-based.
Ah, okay.
Yeah, we have server-based.
So all the image recognition part is based on in the cloud, basically.
Yeah.
Yeah. On page 70, you speak about, try to find that again. Is it page 70? Subjective precision of the system. As we see it, these scores indicate good subjective precision of the system put to test.
Yep.
Can you specify a little bit more what you mean with that?
Yeah, although here we didn't do any comparative user study to compare our system with other system, but when the user write for example, they write 4/5 or even 5/5, something like that, it means that they have some sort of positive attitude to the system.
So it's the user's perception of the system performance.
Yes.
Okay.
Yep.
Mm-hmm. Yeah. Then you make a conclusion on page 71, and you also made that conclusion in your presentation. You say that I'm citing you here, this confirms our conjecture that similarities between photos, especially visual similarities, are good candidates to trigger positive feelings of reminiscence.
Yep.
Now this refers basically to the way, or to the power of your system of triggering positive reminiscence.
Yeah.
But isn't the kind of feeling that is produced rather dependent on the input data that you're looking at? I mean, what I'm saying here is that I'm questioning this conclusion strongly, because I would say that your data set is heavily biased. I would say that most people have a tendency to keep images of positive memories. I mean, I know that myself. If I take a picture of my own and I'm looking a little bit bad, I have one eye closed or something like that, I erase it, take another one. I keep the good ones, right? So we have a tendency not to save bad memories in form of pictures. So how should we expect something different than when retrieving them?
Well, for example, I gave you an example about that my grandmother passed away. So if Facebook didn't remind me about that, I wouldn't retrieve such kind of photo.
Yes.
And I wouldn't.
That's a good one, yeah. You mentioned a similar example in your presentation. But wouldn't you agree that these are probably a minority of the I mean, here we actually have an ambiguous interpretation of images. Images which have been positive at some point in time get a negative connotation in another situation, and probably many years later they will trigger a positive feeling again. But I would say that probably I would claim that probably these images are only a few among many, many others that we use to save in everyday life.
Yeah. So, I mean, of course, using the system, first we avoid that. We avoid triggering the negative reminiscence, and second, because as you mentioned, because we used to keep the images which contain positive moment, but because in the past, for example, when people didn't have the digital image, people just have some sort of physical album, and the capacity of the physical album is sometimes limited, so people have time to browse off them. But when we have a huge amount of photos, we don't have time to browse off them. So although we have some positive images, but we just dismiss that and we just overlook that. So the system will help them to revive the positive moments that they may forget.
Okay.
Yeah.
But you also, as you said, you also claim that it helps avoiding negative reminiscence.
Yep.
But what if one of the participants actually stated a conflict here?
Well, it's just his concern, because actually he didn't encounter any problem like that, but it's just his concern about that. You know, sometimes you see something. I mean, if you are not really strongly a technical person, you see something, but you have some doubt about the system. But we need to, scientifically prove that, whether it's really concerned.
You're hinting a little later on that. You're speaking about randomized studies or random reminiscence triggers. On page 74, actually, last line. It was well received by the user. It remains to quantify, compare our approach with those using random reminiscence triggers. Can you give example of those? What are random reminiscence triggers?
Yeah, you browse the photos and the system just suggests random photos.
Right.
For example, from what you have shared in the past, or some random photos from your friends or something like that.
But then you also should take care that if you run these kind of tests, that the data set in itself is not biased. It should have equal proportions of different kind of feeling triggering connotations. Like there should be an even amount of positive and negative images or whatever. Wouldn't you agree?
Yeah.
Because still, again, I get back to your claim that it's the system that helps avoiding the positive, avoiding the negative and triggering the positive.
Yeah.
I would claim it's basically the content that you're working on rather than the system.
Yeah.
Of course, I mean, on a very superficial level, you could say everything which helps people look up old images, which trigger good image, is a good effort to
I mean the system itself, it just relies on the similarity between images.
Yes.
But it's about us who we determine when and where to utilize that. Yeah.
This is a question on which I revert to later on. Let's proceed to paper 3. This is the DigiMetaplan system, which I found very interesting. This paper has been submitted at the time of printing your thesis. What's the current status of that? Have you received reviews?
The paper was not accepted.
Was accepted?
It was not.
Was not?
Yep.
Okay. What were the major concerns of the reviewers?
The thing is that the motivation, the desire of the system was highly appreciated, but the authors just believed that all the findings in the papers was not sufficient to match the creativity theme of the conference. They expect to explore more about how the system is used during the user study related to supporting creativity.
Okay.
Yep.
So these were more general opinions and comments. There were no technical issues raised. No. Okay. Because I have probably some technical details to discuss here.
Yeah.
I have a first comment is that my impression was that this has been produced it's a comprehensive paper. A lot of text written, and probably you were under time pressure because there are a number of small errors in here of formal nature, nothing content-wise, but there's a lot of inconsistencies in the references. For instance, in the reference list, reference 13 onwards, there's a inconsistency in the numbering, then a lot of bibliographic information missing. But these are, again, technical details, but they stick into the eyes of the reviewer also at first glance if they see a paper. I have a list here. I can pass it over to you later on for details.
Yep.
The first thing that caught my attention here was that when looking into your review of related work in this paper, which would be on page 86, well, that seems plausible to me. Then I was surprised to see that there is not much recent work here. Most of these papers are dating back 20 years ago. Most of them 10 to 15 years ago, which is fairly long time within this field, which is developing so rapidly. So why is that so? I'm sure you have done a great job in doing your literature study here. So well, I assume there's another reason for not being more recent similar systems to be cited here.
Well, it's not. I would say that there are many papers that are not really about 15 years ago. I think that, for example, Telebor, which is just 4 years ago, Telebor in the third paragraph is 4 years ago, or even
Firestorm is 6 years ago.
Yep.
It's yes, that's the most recent one I can spot, and also the Teleboard is 6 years ago.
Yeah.
These are the two most recent ones, and there's one of 86, beginning of the 2000s. I mean, you don't have to pinpoint it exactly to the year, but there is a bias towards, most of them are, I would say, traditional papers. Having been around for several years. What do you have an interpretation of that? Again, don't take it as criticism. But,
no.
It might mean something different, namely. This is what I ask you. Could there be is there any explanation for that?
Well, I would say that I have been doing the literature very heavily about this, and I was also pretty surprised by why people underestimate the role of remote participant using mobile device in this kind of activity. And it's true because no one really look about it.
Would it be too tough to say that probably this field or these techniques are researched to an end? Well, that's a very provocative statement. Like the kind of technical facilities that you incorporate. After all, you're talking about a concept.
Yeah.
You're not creating a novel new system.
Yeah.
You're presenting a new embraces existing technology.
Yep. Yeah, I would say that it's also a problem because right now, if you want to enhance the interaction of user on mobile device, it's very likely that you have to introduce new hardware. And in order to capture more things, more stuff, I'm not pretty sure whether other researchers are viewing the problem on that perspective or not. But yeah, if we just rely on the existing commodity device, is people probably will perceive that there is nothing to advance there. And another thing is that because the aim of the paper is to design a solution for facilitated brainstorming. And I'm also pretty surprised that facilitated brainstorming in remote setting is not explored much as well. So yeah, sometimes you just go into some direction and you surprisingly found that no one is working on that almost.
Yeah. Have you thought of virtual reality as an environment to conduct these kind of meetings?
We are working on that right now as the next version of the system.
Yeah.
Yeah.
Because I'm not sure, I did not do that search myself, but I would assume that people have been looking into fully virtual distributed collaborative systems, probably also for the type of brainstorming meetings that you did.
Yeah.
If you look into games facilitate nowadays a lot of very advanced interaction where we see virtual embodiments of the participants, which help us convey gestures which are difficult to convey through your system, as has been pointed out in your study.
Yeah.
The real free air gesturing part is something which is very difficult for the remote users using the video conferencing system.
But there are some things that we have to consider when using virtual reality here, because the first thing is that when using virtual reality, whether the user will see the workspace on the tablet like this, or whether they will wear the VR device like this. Because when they wear the VR device, they probably have the problem with inputting idea, because inputting idea in air is very troublesome right now. So we have to consider whether we allow user to use VR device or use this one.
Yeah.
And another thing is that how to visualize the facilitator and the people in the room. Whether we, for example, imagine that we visualize them using 3D model. Whether we need to capture the point cloud of them and visualize that on the tablet or not, because it's going to be extremely expensive for the device to be able, for mobile device right now, to be able to render such kind of thing.
Yeah.
Yeah.
I mean, I agree. There's a lot of other technical problems inherent to these solutions.
Yeah.
You're right. You use and I reused your
Well, I would say that on the because the framework mean here is not just only the user interface, it's also the way that we exchange the information between different devices. We have to build a cloud-based system for
Yes.
exchanging the information.
So framework also contains metadata, protocol descriptions,
Yeah.
kind of that.
Yep.
Okay. Somewhere on page 89, it's a small detail to say, you put forward one of the advantages of the system. This feature is the advantage of digital brainstorming. The feature you refer to is changing colors of the nodes. I'm not evaluating this advantage, but what is the color expressing? I would be curious to know here.
The color changing?
Yeah. You say
So-
that color the ability to change the colors of the nodes is a big advantage of the system.
Yep.
What do you use color for? What does color encode in your system?
The color encodes, well, what the color encodes, it highly depending on the content of the brainstorming and the purpose of the user study. And what we observe in the user study is that the user tend to change the color of the nodes belong to the same cluster to differentiate different cluster.
So it's up to the user to
Yep.
decide why
Yep.
colors.
Yep.
Okay.
Yep. And beside this system, we also modify the system for the industrial partner in Zurich. And for them, the color will indicate the creator of the node as well. But when we do that, it doesn't follow the initial design of the system. Yeah.
Okay. Have you considered other ways to enriching your nodes in adding more meta information to your nodes? I mean, you have color. Have you considered tagging using icons or text tags? Is that something which you have discussed?
Yeah, I mean, right now the node is just something that the user write. I mean, because in the system we suppose that the creator of the node is anonymous, so we didn't display the information about the creator of that. But if depending on the use case, that probably necessary. But in the system that we design and we perform the user study, we didn't get more requirement from the participant about more information needed for the node.
Fine. One of the problems identified in your experiment here was that that the video stream, which you right now handle as a separate independent Skype window,
Yeah.
then thus that this was not enough prominent and gave little
Yep.
detail.
Yeah.
At one point you say that you're using a 13 megapixel web camera,
Yeah.
which is excellent number of pixels.
Yeah.
But then you have a few hundred pixels edge length of your
Yeah.
Skype window.
Yeah.
I assume that you wanted to keep down the development effort and plug together existing tools. But wouldn't it be in particular for the remote user, be interesting to have also a digital metaplan client that utilizes a larger screen? I'm not saying that that the remote user is supposed to have a wide screen with touch interaction, but simply using a normal state-of-the-art desktop computer screen showing the contents of the metaplan desktop.
Yeah.
Because that's
Then they will for sure encounter somehow similar problem, because if we run the user study, I mean, if we use Skype on the laptop right now, and we run another application at the same time, and Skype window would be displayed as a portion on the screen as well. So, because in the brainstorming session, we need to, the video stream need to carry out a lot of information about the gesture and the people in the room as well.
Yeah.
So, if we display the video stream in a small window, even though it's just on the desktop, probably, the remote participant probably also encounter a similar problem. Yeah.
But the solution would then mean that you have to integrate the video into your own application in order to make it bigger.
Yeah.
If you would integrate it fully into your metaplan.
I was also considering using two devices. For example, one device for the canvas and one device for the video stream. But you know, at that time you have the eye switching problem between two workspace as well. Yeah.
I mean, you have these problems. You mentioned them on page 92.
Yeah.
You say the field of view could not cover everything, and so on further.
Yeah.
And you use the configuration, and I found that also quite worth mentioning. You use the configuration to the current literature 6.
Yeah.
This reference is from 2003.
Yeah.
That's 14 years ago. And I would expect that, or not expect, a lot of things have happened on the camera side, web camera side, both in terms of optics and, as you state yourself, in regard to the pixel resolution. Might be worthwhile thinking of other camera configurations that capture the co-located group more comprehensively.
Well, actually, I think that there was one reference missing there during the time I was writing. So, for example, the system teleboard, it was developed in 2011. I would say that is one of the latest one in this topic, and they also use the same setup of a camera as well.
Okay.
Yeah.
It was just because I encountered this citation right next to the statement that this is current recommendation.
Yeah.
That was interesting. Okay. And then I have a few questions regarding how you present your results. If we go to page, we start with page 96, which is representative of other passages in the text. You say a total of 4 hours and 24 minutes was recorded, so you had 5 sessions, right?
Yep.
So on average, every session was 45 minutes. And then you say standard deviation is 16.8 minutes.
Yep.
Why do you show standard deviation? Why do you explicitly state?
Because probably there would be the question about the length of each brainstorming session.
Yeah.
Some group probably just run. People probably question. Okay, probably some group they just come there for you to be a participant for you, and they perform just in 15 minutes and then 20 minutes. But some group, for example, I mean, because in the user study, as I mentioned, although we have some default topic for the session, but the group can also bring their own topic as well if they are working on that, because we want to increase the engagement of the remote of all the participants. So there probably some critic that some participants just came and then they perform 15-20 minutes while the group.
I get your point. Basically, I was targeting towards a different direction. The standard deviation is interesting if you have a big data set and if you know how that the database you assume it's normally distributed.
Okay.
But here you only have 5 observations. You have only 5 times. It's okay probably to calculate the average, but it would be more interesting to show the minimum, the maximum, and the median.
Okay.
Then you would have shown already more than half of the entire data set in this particular case. Okay. So it doesn't make sense to show standard deviation. It doesn't say anything in this particular situation. You have that in many other places also.
Okay.
We can go to page 99. And there I have to ask you the following. It's about the ANOVA testing that you did.
Yeah.
And now I'm referring to the middle section, central section on page 99.
Yep.
In the ANOVA, what were your factors and conditions? What did you measure here? It's not all clear to me. What in this first ANOVA test, what you tested?
So in the first ANOVA test, we test, for example, the remote participant rate themselves, the collocated members rate themselves, and the facilitator rate themselves. So we measure if there is any difference in the way that they rate their own performance. In that case, we measure if there is any difference in their ratings, in the self ratings or not.
Yes.
Yep.
So in each, you have a two-dimensional scheme, to say. You have different conditions, and in each of the conditions you have samples, data values, and the data values are how many data samples do you have in each of those conditions?
So, for example, with the facilitators, we had 5.
Yes.
With the remote participant, we had 5, and with the collocated members, we had totally 10. Yep.
So it's very little data in each of the conditions.
Yeah.
Paragraph. First you do the ANOVA in order to see if there are anyhow differences, and later on you do post hoc testing using the t-test. First off, did you any test on the distribution of the data?
Yes, we did. We checked distribution on the log of the data.
Yeah.
Yeah.
Okay, and it showed to be normally distributed.
Yeah, I mean we work together with a statistician about that. Yeah. Yeah.
That's interesting here, because then the next question was in regard to the turn rate, and you measure it as the percentage of total turns of a group.
Yep.
Right. And then you compare them using the ANOVA, and you do this percentage within each group. And here I would say you're doing a quite fatal error, because you can't compare these data sets. Transformation. For instance, if you look at the remote participants, you had 5 observations, right?
Mm-hmm. Yep.
So you only have 5 values.
Yep.
And then you calculate the number of turns reported by the remote participants. Why don't you compare the number of turns and instead transform it to a percentage value? Because if you, at the end of the day, you have you assume some kind of distribution of 2 data sets.
Yep.
In fact, it's more data sets because you're using the ANOVA.
Yep.
But each of your data sets here, in the different conditions, the groups, the remote participants and the facilitator, they might have different absolute values.
Yep.
Right? But in your transformation, you never ever can have more than 100% here, right? In fact, you will have only 4 or 3 different observations here, which are discrete. And 50% in this data set might mean, I don't know, 20 turns. But you have another data set where 50% means 100. So if you compare them after transformation, you won't see a difference, but in fact there would be a difference.
I think that using the absolute value here is something suitable, because it depends on the communication within the group. So in the group, for example, if they perform 20 minutes of the brainstorming, they obviously have more turn taking than the group, less turn than the group which perform 1 hour. So
yes.
So that's why here we consider about the contribution of each participant in the group. So that's why I just consider about the relative value between the.
I accept this argument totally, but what you said is then that you would relate and normalize for time. And then you do the normalization equally for everyone. You would count the frequency per minute or per hour or per second, which is the same for everyone. But here you might end up in that you're normalizing differently based on the number of observations in each group, which you don't have control over, and which is different for the different groups.
Well, I mean, for example, if in for example, in a group, the user mainly communicate. For example, they mainly communicate because of some problem. Although they have pretty lengthy brainstorming session, but the verbal communication is, not that much. But they convey via their gesture or something like that. So then if we count the number in that way, and then we compare the frequency by turn per minute, probably is not also a good way to consider the contribution of them, because it's not fair. Probably you generate 500 turns in 1 hour, but in our group they have 30 minutes, but they also generate 500 turns, and then comparing participants in those two groups using.
Yeah, but that would give you a more objective scale to compare with. Then you could at least draw the conclusion that, referred to a time interval, this group performs more interaction than the other one.
Oh, yeah. Yeah, it's one way to consider the interaction and communication between groups. Yep.
Okay, let's forward to paper 4. This is a nice idea that you present there with the finger-worn concept. Again, you use the term concept. It's a very short paper and only hinting on the idea. I think there's a lot of more interesting stuff to be done here, in particular related to this work. Can you give me more insight into the technical details? For instance, I would love to know about this ring device. Is it something which is off the shelf, or did you develop that on your own?
No, it's not. It's not off the shelf device. It's something that we made in our lab.
You made it on your own.
Yeah,
oh, that's great.
Yeah. So
and
we had to.
What does it actually measure? I mean, of course, it can sense acceleration.
Yep.
And do you also infer 3D position in space?
No, it is not possible to do that, because in the sensor it has the accelerometer, it has the gyroscope. So magnetometer as well, but it cannot measure its relative position in the space. It cannot do that. Yeah.
Okay. Yeah. This vibrotactile unit. You can modulate the amplitude, as you said, and the on-off period length. Is it also possible to modulate frequency with these devices? High frequent or low frequent vibration?
The frequency of a vibration pattern is actually the gap between two units.
Yes.
So if you have a long gap between two units, then you have a low frequency.
Yes.
Yeah.
So what you're actually employing some kind of a pulse code modulation scheme.
Yeah.
You frequency.
Yep.
Like this. So what you're looking at are these periods.
Yep.
Right.
Yep.
My question was: is it possible to alter also this frequency here?
No.
Impose some frequency modulation.
Well, I would say that the amplitude here is referred to the strength of the frequency, because it's the device describe the strength of a vibration.
Strength,
so,
yes. The amplitude,
Yeah, the amplitude. So it's expressed by the frequency of one unit. For example, if we suppose that a unit is like 50 milliseconds. So if we have a high frequency, then we're gonna have a high strength, and if we have low frequency, and then we have a low strength. It's the way to express the amplitude.
Ah, I see. Now I understand better.
Yep.
Yeah. Okay. I have a few questions about the kappa, because we're also approaching lunchtime soon. These papers are all from 2016, and the latest paper has been submitted and has been, is probably under revision. How is the coherence between these papers? Is there, I mean, you have been working for 2 years on your project.
Yeah.
Has there initially been a research hypothesis and you have developed from that these different works, or have they been started spontaneously, more or less in parallel to one another?
Yeah, I mean that my PhD thesis, my PhD study started with the Merkle project, which developed the digital meta plan.
Yeah.
So it's actually the aim of the meta plan at that time is just develop new software solution to resolve the problem of remote collaboration. And the other works, the other papers, they came when I started to have the connection with our academic partners, and they brought up ideas and they asked for help or something like that, and then I got involved into that.
Yeah.
Yeah.
Usually, to be more specific, usually when we start new PhD projects, the students have to apply to be enrolled, and there we state a preliminary thesis title, the subject of the title.
Yeah.
Has this title been, at the time when you started, already contained elements of the title that you present now? Now your title is Towards Enhancing Awareness in Designing Collaborative Computing Systems.
Yeah.
Has it been a similar title?
No.
No.
The initial title is Supporting Remote Collaboration.
Yeah. Okay. Yeah, which is much more
narrow,
closer to the digital meta plan, meta plan. Yeah, I see that.
Yeah.
Yeah. But of course, I mean, PhD studies, they go like this. You have to somehow find the right exit at some point.
Yeah.
It's quite natural to do this way. But I have nevertheless again a question regarding to your title here. You say Towards Enhancing Awareness in Designing Collaborative Computing Systems. There's a kind of an ambiguity here in the title to me when I read it. It could mean like awareness in the design process. Is it this what you want to express? Or is it the awareness of the system? Or
is the way in order to integrate awareness in collaborative system. So it can be understand that the system is the way that we can integrate the feature so that it improves the awareness between different users when working with it. Or it can make the computer more aware of its user.
Okay. So the subject who is aware of it could be the user or the system.
Yeah, yeah.
That's good. That would have been a good point to develop a little bit further in your kappa, because it doesn't quite get over this message. I appreciate your definitions of awareness, and they helped me quite a lot because they went a little bit beyond of what you write in your kappa.
Yeah.
Your kappa is a little bit unclear in regard to what you mean with awareness, and it doesn't either make it clear to me how the different pieces fit into this awareness creation situation or process. Yeah. I have another definition of awareness. I picked it from the Cambridge, the language definition of the English language dictionary, the Cambridge dictionary, where it says knowledge that something exists or understanding of a situation or subject, which is very much like what you had, at the present time, based on informational experience. For me, and also in the language, in the dictionary definition, the time aspect is important also.
Yeah.
It's about here and now. It's about between you and me right now in the situation, or the system and me.
Yeah.
And that triggers a question in me: how would you justify paper number 2, the photo reminiscence paper? How would you justify this in context of the heading of your kappa? Because
you are viewing the photo as the present. You are viewing some photo, you are sharing some photo.
Yeah.
It very highly that is your interest at the moment, at the present.
Okay.
So if we can trigger something in the past, relevant or similar to what you are having right now. So because what you're seeing right now is something that you're interested in, so it's probably very positive for you. So if something in the past similar to what you're being right now, it's very likely to be positive to you as well. So it means that the system aware of what you are doing at the present to trigger to bring up some memory in the past for you.
Okay.
Yeah.
So what you say is that basically what you use, the image that you're searching for, this is a sample, this captures the current situation.
Yeah.
Ah, okay, that makes it a little bit clearer to me, because I perceive this as being a general tool for putting in any kind of an image and searching for the most similar images. It's really about this image taken here and now. Ah, all right.
Yeah.
That was a very good clarification.
Yeah.
That was important. Yeah. In the summary description, you also start describing this this entire issue of territories in tabletop displays.
Yeah.
And I wondered a little bit why do you put so much emphasis on this? Why is the territories? How do territories relate to awareness? And why is it important?
Well, I just put a lot of description about the territory because I'm just afraid that the reader couldn't grab all the idea about territory on tabletop, so that's why I just try to make it clear.
Okay.
Yeah.
But then I thought there might anyway be a good idea to use the territories. And I would like to ask you, would it be possible to use territories and how they are defined on the tabletop in order to measure awareness?
Yes, I think so. For example, if you want to, for example, in measuring the workspace awareness, let's give an example. So the system, for example, I'm sitting like this, other participant is sitting like this, and suppose that we can determine the personal space of each participant, and we will see if there is any violation of another user on the personal space of a user or not. Because if we have several violations, it means that the workspace awareness is not very well maintained in the system. Yeah. Or for example, in contextual awareness as well. Contextual awareness, it means that, for example, imagine that the tabletop can provide the user interface or the tools suitable to the current task of the user. So, for example, user is working on this, instead of providing the tool to manipulate this content, the system provides some other tools which are not suitable. And then we can control that the system is not very good at supporting contextual awareness.
It's worthwhile thinking of it because if you make a claim here or have it at least included in your title, enhancing awareness, you have to think of ways to quantify awareness.
Yep.
Otherwise, it's very difficult to
Yep.
draw any conclusions. You have to find some kind of empirical results and have evidence.
Yeah.
Okay, I will skip a whole bunch of different things and would like to talk now a little bit about my personal reflections and suggestions probably for the remaining time, and give them over to your supervisors and to you.
Yeah.
So, first of all, I think this is very good for good work that you've done for a license. It's thesis. I'm not the one who's supposed to do some grading here, but I would very clearly express my favor of your work here, and it's certainly very good work, comprehensive and so on. But there are also, which I have to say, some things that should be taken care of in the future. And the following would be my recommendations, things that might be good to consider. First is ethical considerations. Ethical considerations must be included in at least not only in the papers where they are relevant, but also in the thesis. And I think in this kind of research they are also relevant because, I mean, as your studies show, there are concerns by people how they experience things, bad feelings can be triggered. And whenever you start sensing people, what they are doing, you're monitoring people, then we are getting into the topic of
privacy,
ethical aspects. So don't miss them to discuss them.
Yeah.
Regarding the bibliography, there are some technical things there, of course. They have to be a little bit more careful probably there. And in some places, I really was not sure if the current research front was really covered. I'm not the one to tell this from expertise in this field, because your field is very diverse a little bit, and I'm not really an expert in any of those fields myself to tell it. But I simply went to looked into the chronology of the papers and found some oddities there. One thing which is certainly interesting for you in order to elevate the quality of your research and impact, not quality, impact of your research, is that at some point you have to go and publish in a journal, right? And looking into your papers, I see that you're mostly citing journal symposia papers, which is quite natural in the discipline. I'm aware of that. But there are very few references to HCI journals in your papers. For instance, paper 4, there are 11 references in total, and only one is a journal article. Paper 3, there are 39 references. There are 8 journal papers, but only 2 of them in the HCI field. Paper 2, you have 41 references, 9 of them are journals, only few in the HCI field, many others in completely peripheral fields. What I'm saying with this is that probably try to work more with journal articles, because it also gives you a better understanding of what the type of presentation and depth of research would be in order to really position your work in those journals. Then there is the red line of awareness. I'm not sure how you are going to continue this work now. If it's going to be awareness, if this is the major thing. I see the good potential to continue under this subject heading. But then you should really actively work towards linking your research to awareness questions. Try to get results that really allow you to draw conclusions on awareness, increasing effects. Try to compare different technical solutions and measure awareness. Try to quantify it somehow and try to investigate effects. That would be, because at the moment it is a little fuzzily defined, I would say.
Yeah, I mean, I acknowledge that. I appreciate your suggestion. Well, measuring awareness, especially in order to run comparative user study, I was thinking about that, but it turned out that sometimes it was challenging for my setting right now to do that. For example, in order to measure the awareness in the digital meta plan system, you need to recruit groups of participants who know each other. And it's very hard to find a good group. And even when you can find a good group, they can spend maximum 2 hours with you. And if you want to run comparative user study, you have to ask them to come twice. And
I know. Whenever you do user studies, it's a lot of time. It's difficult to recruit participants. I agree with you. So the lessons learned here would be try to cut it down, make it simple. Try to isolate the tasks, try to isolate the population. You lose a little bit of ecological validity in your studies, but that's often overlooked by the reviewers anyway. So try to keep the studies simple and narrow them down on very easy tasks, which which is easier to make statements on. I also found, I'm not sure how you planned on your own. The last paper, which is only a sketch of an idea to me, contains some parts which might be interesting to study further. For instance, the type of vibrotactile feedback, the pattern, you could very easily modulate different vibrotactile patterns. And look at the response in users. The response in terms of, does it capture awareness? Does it distract users also.
Yeah.
That would lend to very nice quantitative experiments and studies, which might be good to publish.
Yeah.
I think I'm fine here. These were a few suggestions, comments, and I'm happy to discuss further after the official part here also. But this is what I had.
Yeah, thank you very much for your suggestion and advices.
Thank you.
Yeah.
Thank you.
Okay, thank you very much for this session, and now we leave the floor to the supervisors, and Michael is here. He might have questions. Okay. Okay, so let's see if we can get Andreas in. He doesn't have questions. Okay, good. So we save a bad line there. And well, I don't have any questions right now, but the recording here will give material to very interesting discussions in the following weeks and months.
Yeah.
So that's very valuable.
Yeah.
Yes, but I don't want to jump into anything particular right now. Okay, so to the to the public, is there anyone else who have questions? I hope it would be great. Gordana, I'll give you the mic.
I have just one very short question, because I'm moving from the cognitive science to your interaction design, and I wonder, do you see any possibilities to collaborate with cognitive science, especially on this topic of awareness?
There are several opportunities to collaborate because we are working on technology, but my knowledge about cognitive science is very limited. You are working on cognitive science, so you have knowledge, much more knowledge about the scenarios where we need to evaluate the cognitive problem of user. So sometimes you don't know how to, facilitate the cognition of user or something like that. So if you want me to come up with some technology or design to facilitate that, then I'm very willing to collaborate. Yeah.
Yeah. So anyone else? Feel free. I mean, there's still time. No, doesn't seem like. Okay, so I think we round off the defense then, or the session.